This video is going to cover how to multiply complex numbers. We'll do a couple different examples, some like this, some that looks a little bit different, but again, all we're doing is multiplying. In the last video, if you watched it, we discussed what a complex number was and what they look like. Remember, they have the i's. Remember, I stands for the square root of -1. Okay, and then along with that, remember we wrote down also that we had I squared equals -1, and we talked about how to get that. And then I to the third power is equal to -I, or negative square root of -1. And then we also talked about I to the fourth being +1. We're not going to use all of that in this particular video, in this particular section, but it's still something that we need to be aware of. So in this particular instance, I have a complex number here, a complex number there, and it looks as though they're a binomial, and it really is. So I'm multiplying binomials. So remember, if we kind of go back to our multiplying binomial section, there was a couple different ways we could do it. One is we could FOIL, and for those of you that want to FOIL, be my guest, go ahead. Another way we talked about is multiplying it with a box. And then we talked about also the distributive property. Whichever one of those you can do. Remember, binomials and binomials we still can do with FOIL. If I have a binomial and a polynomial, then I cannot use FOIL. I'm going to use a box. So I'm going to put -7 minus 2i on top of the box, and I'm going to put 6 minus 3i on the side. Now I just multiply like I normally do in any box. So this is -42, this is -12i, this is +21i, and then in the last box on the bottom right, I get 6i squared. So if I look at this, again, diagonals I can combine, okay? So that diagonal I can combine, I get 9i. The -42 is going to be out front, and I have a 6i squared in the last box. But when we talk about a complex number, remember it's a plus bi. It says nothing about squared terms. But I have a squared I here. Well, if I look at an I squared, it actually goes back to -1. So in this case, that 6i squared turns into 6 times -1. So this really turns into just -6, which can then be added to the 42 that's negative in the front. So final answer is -48 plus 9i. I combined the -42 and the -6 to get -48. The 9i just is written at the end because there's nothing else I can add to get it. Let's try this one. Well, what does this 2 actually mean? It means that I have 2 of the binomials, the complex numbers. And then I have 2 binomials, right? And then so I can multiply in a box, FOIL, distributive property. Let's do a box. So I'm going to put 1 of the -3 plus 7i's here, -3 7i's on the side, and just multiply through. So 9, -21i, -21i, and this is 49i squared. But remember on the last one that this I squared equals -1. So that's going to turn all of this box into a -49. You notice, if we want to think about kind of looking at math a little bit differently so it looks easier, all I'm doing whenever I have an I squared is taking the number that's in front, the coefficient, and flipping it. So it's +49i squared, so now I got to get rid of the I squareds, it becomes a -49. I'm just flipping that 49. The same happens to every time you have an I squared. All that occurs is the number that's in front, the coefficient, just flips its sign. And then combine terms. So the 9 minus the 49 can be combined to give me a -40. And then the -21i and a -21i can be combined to give me a -42i. Let's work on this problem. I'll show you 2 different ways to do this one, depending upon which way you want to do it. Will be easier or more difficult, again, choosing which way you want to do it. So I am going to, if we look at it, we have a monomial, and then a binomial. So it looks as though I have like a multiplication with the distributive property and kind of all of that embedded into this problem, which that is true. I do have all of that. So your choice is to choose what you want to do first. So let's do it this way. I'm going to take this negative 6i and I'm going to distribute. When I distribute, I get 12i plus 18i squared. Remember, I times I is I squared, and then I times no other I is just the I value. So what did we say in the last couple problems? That whenever I have an I squared, this actually turns into a negative 18. And the 12i is still in front. Okay, we're not looking for an answer yet, so I can leave it this way. I don't have to write it as negative 18 plus 12i. You're more than welcome to do so. It doesn't matter right now. Then I have the 12i minus 18 times the 6i that I didn't touch yet from the beginning. Then I'm going to distribute this. So that's 72i squared minus, now 6 times 18 is 108i. Again, we said that I squareds give me a negative 72, the opposite of the coefficient, minus the 108i. Can't do anything with it, so this is my answer. Now, like I said, there's more difficult or easier ways depending upon how you want to do this. So let's go through this problem a different way. Maybe it'll be easier for some of you. Maybe it'll be harder. I don't know. We're just giving the options here. So I'm going to leave everything up here that I already did, but I'm going to show you another way from the beginning. So I'm going to mark it off here. So everything there is one example, and then the one below it is the other way to do it. So I'm going to I have my 6i times my negative 6i times negative 2 minus 3i. I am going to multiply the first two first. So that's negative 36i squared, which, if we recall, turns into a positive 36 times negative 2 minus 3i. Now I distribute that 36 through. Negative 72 minus 108i. So there's two ways to do it. You could either multiply the two monomials first and then binomial, or multiply monomial, binomial, and then the other monomial with that remaining binomial. So it's basically distributive property two times or just one time. It's up to you. No matter what, you get the same answer. This is going to be the last example for this video, and all it is just a monomial and a binomial. So all we're doing is distributing. So 7i times 3 is 21i. 7i times negative 7i is minus 49i squared. Again, this turns into a positive 49 plus the 21i from the first multiplication step. And because now it is written as a plus bi, I am now done. This video has covered multiplying complex numbers, whether they be monomials and binomials or a combination of any one of those.